Let us talk about calculus. I guess you all are familiar with the equation of a line. We all have studied it in our school days, right? We write it something like y equals x, where if we have this line, then at every point on the line, the value of y depends on the value of x. For example, if x equals 2, then y equals 2, right? This relationship shows how y changes as x changes. But this kind of relationship is easy to visualize because it's a straight line, constant and predictable. Now, imagine you're a curious thinker in the 1600s, when the world was just beginning to explore the motion of planets, the falling of objects, and how things move and change over time. Straight lines didn't cut it anymore. Things in nature didn't always behave predictably or move in straight lines. Think of a ball rolling down a hill or water flowing into a basin. How do we even begin to describe such motion mathematically? Let's go back to the straight line for a moment. A straight line has a very special property. It has a constant slope. The slope tells us how steep the line is. That is how much y changes when x changes. For y equals x, the slope is 1, meaning for every one step forward in x, y goes up by 1, right? Now consider another line, y equals 2 times x. The slope of this line is 2, meaning that for every one step forward in x, y now goes up by 2. In other words, this line is much steeper than the first one. Therefore, slope is like a measure of the line's steepness. It tells us how fast y is changing compared to x. Now, imagine a situation where the slope is 0. For instance, if you have a line like y equals 3, a horizontal line, then we know that the slope of this line is 0, because y doesn't change at all, no matter how much x changes. On the other hand, if the slope is a very large number, the line is super steep, almost vertical. I think you understood my point. But then, someone like Galileo might come along and say, what about something like y equals x squared? That's not a straight line. It's a curve. For example, we all know that distance equals speed into time. Now assume you are running at a constant speed, say 2 meters per second. So d will now be equal to 2t, where d is the distance and t is the time, right? Now if I draw this graph where I put time on x-axis and distance on y-axis, then we get this straight line, and the slope of this line will be the same as your constant speed of 2. But now, assume you start running in a race, and instead of maintaining a constant speed, you begin slowly and then gradually speed up. At first, you might cover only 1 meter in the first second, which is equal to this point, then 3 meters in the second, and perhaps 6 meters in the third second.